Welcome to the FMSP online revision. This session is for M1, AQA M1. Topic is kinematics, and we're looking at question 2 from January 2010. So, looking at the question first of all, so a sprinter accelerates from rest at a constant rate for the first 10 metres of a 100-metre race. He then takes 2.5 seconds for those 10 metres. We're asked to find the acceleration of the sprinter during the first 2.5 seconds, to show that the speed at the end of that time is 8 metres per second, and we're then told that the sprinter completes the 100-metre race travelling the remaining 90 metres at a constant speed of 8 metres. Find the total time taken for the sprinter to travel the 100 metres, and lastly calculate the average speed. So let's have a little look at what we've got first of all. So parts A and B involve this first 10 metres, and in that first 10 metres we're told that it starts from rest, so we know that that means that u equals 0. We're only concerned in A and B with this first 10 metres, so we have s equals 10, and we're also told that he takes 2.5 seconds to run that 10 metres. So in part A we're asked to find the acceleration, and then in part B we're asked to find the velocity at the end of that 2.5 seconds. So I'm just combining that information for the two parts. So in part A we have u, s and t, and we're asked to find a, so we could use s equals ut plus a half at squared. And that means that s is 10, u is nothing, so we have a half times a times t squared, 2.5 squared. So if we multiply by 2 and divide by 2.5 squared, we have a value for a. 2.5 squared is 6.25. If you divide that into 20, you get 3.2. So 32.2 metres per second squared. So that's part A, we found the acceleration. Now what we need to do is to find the velocity. And the easiest way to do that really would be to use that acceleration and the equation v equals u plus at. And so v will be equal to a, which we now know is 3.2, times the time 2.5, which is 8 metres per second. So those first two parts, as I say, concern the first 10 metres of the race. In parts C and D, we're now looking at the remaining 90 metres of the race. So notice that for these remaining 90 metres, he travels at constant speed. So although we can think about using s equals ut plus a half at squared, if he's travelling at constant speed, then of course a is 0. We'll put that in brackets, so a is equal to 0, so we can effectively rule that out. We're told that we've run 10 metres already, so we've 90 metres left at a constant speed of 8. So the time is going to be 11.25 seconds. 90 divided by 8. Now we want the total time for the 100 metres, and of course we took a certain amount of time for the first 10 metres, 2.5 seconds it was. So we have to add the 2.5 seconds to the 11.25 seconds, and we get 13.75 seconds. So that is our total time. Again, always better to give your answer to 3 significant figures. Sometimes they take a mark off for that and sometimes they don't. I don't think in this particular case they did, but it's always a better idea to do it really. So the last bit then, so that was part C, let's just write that in, and then in part D we're asked to find the average speed. So the average speed, we need the total distance divided by the total time, and of course we know that the total distance is 100 meters, so that was the race. And the time now we've just worked out. Now do be careful that you make sure that you use the unrounded figure, so you do want to use 13.75, and that gives us an answer of 7.27. That's to three significant figures. It's speed, so we give the units meters per second. So there were 10 marks of the question altogether, so let's just go back and have a little look at how those marks were actually awarded throughout. So in that first part, part A, there were 3 marks. So you got a method mark for using S equals ut plus a half at squared, and then you got an accuracy mark for substituting it all in, and another accuracy mark for getting the answer here. And then in part B you got just a statement mark, a sort of mark independent of the method, if you like, for writing down 90 equals 8. Oh no, wait, we're at the wrong part. So there was a method mark, sorry, for using v equals u plus at, and an accuracy mark for getting 8 seconds. And this is where I was about to say there was a mark independent of method for constant speed, so that the speed is equal to the distance is equal to speed times the time, just for that. And then a method mark for realizing that you had to add the 2 times together for the 2 parts of the race, and the accuracy mark for getting your answer of 13.8, or in fact 13.75. They weren't being too fussy there. And then the last little bit, a method mark for finding, knowing that it was total distance over total time, and an accuracy mark for 7.27 meters per second. Right. So 10 marks in total for the question. So don't forget that if you want to go through another set of revision videos, then you can do so by going to the Further Maths Support Programme website and following the link to online revision.